Look at that. That's a nice light.
Oh, yeah. Well, what's the question about the universe? Where did it all come from? And then they came
No, I
up with
don't
the
know
Big
that
Bang
there's any
Theory?
question about it. It's just,
Where did that planet come
what
from?
is it? What is it made of?
All right, what is it? It's a Big Bang.
What is it made of, man?
All right, what is it made out of?
Yeah.
Stuff.
Stuff. That's it.
You gotta define stuff now. Well, it's a bunch of energy that solidifies.
Now
But the
that's the sticky wicket.
solidification of the energy
Yeah, we can make matter into energy,
seems
but
to
nobody's
be...
been able to turn the energy into matter yet.
Yeah, I mean, the substance of it is not as important as, the structure of it. What keeps it existing? Because whether it's solid, liquid, air, or what is proposed as ether, but there's no proof for ether.
Well, I think Michelson
It's vibrating.
was
Everything's
terribly
vibrating.
upset because he couldn't prove that there was an ether. Instead, he ended up proving that there was not.
How did Michelson give it any validity? How did he define
They built an interferometer on a big table.
interferometer?
Yeah, and it had light that was going between mirrors and across. So it was going up and down, like like to these cardinal points.
Mm-hmm.
And then they turned the turntable, so that it was going, it was going down another path. And they wanted to see whether or not it changed any in the interference patterns that they had, And to indicate that the Earth was moving through a medium, and that there would be some Doppler effect, which would be noticeable with the interferometer. You see?
Mm-hmm.
And there was no Doppler effect. The effect was exactly that. There is no medium out there that will change frequencies when the Earth moves through an area, you see? So if the Earth is moving, the Sun is moving, so all of these things are in reference to one another, and so everybody just had to throw up their hands. And Einstein came along and said, well, the only thing that's, you can say is that it's relative. The movement of one thing is relative to another thing,
It's relative, but there's space, right?
Space is only another relative function of distance and time. You see?
Space is a measurement.
I mean, rate in time. Space is how far out you want to measure it in the directions that you have to go, and you can go in 6 directions if you want to go at 90 degrees.
No, I'm not saying it's just like it's the distance.
Yeah.
I'm not measuring it. I'm just saying that between here and there, there's obviously something in between. That's called space.
Intuitively, we feel like there is something other than this, but Einstein was saying it's just not so. And time and space are simply the measurement of the stuff that you're talking about. This is the reality.
3 dimensions.
And
visually,
and
we're using our senses.
And there's apparently redshift. The universe is expanding. Not only it's accelerating in its expansion, and this causes distant galaxies' spectra to be shifted way into the red, so that they look like, so that the lines that represent the elements that are in the spectra, like that are in the stars,
Mm-hmm.
in these galaxies,
Mm-hmm.
are displaced a long ways because they're traveling away from us, and so it's a lower frequency. So they're more red,
All of them are doing that?
Yeah, all of them are way out there, are moving away so fast that they look red. It's shifted toward the red. All of the frequencies are shifted downward.
Have they looked in every direction possible?
Oh, yeah.
Okay, so they found that.
Now,
so then nothing else is doing
the
anything but
steady
redshift.
state thing,
What is
to
what degree?
Somehow there is hydrogen that appeared somewhere, and and then it somehow got gathered together by gravity, and started these. I think black hole theory came before the Big Bang theory, So gravity was doing this thing, right? Which of course is another thing that they don't know what it's made of.
I know, no. We're gonna conclude on gravity, but go ahead, continue with the other part. Yeah, we're talking about gravity.
Yeah. Anyway, the other part is that the excuse me, I'm giggling so bad I can't recover my
Okay,
train
now
here.
let's go into gravity then. Here's what I'm going to say about gravity. You always said something interesting that I don't really find to be that strong of a point, but you say that if something's rotating, something's revolving around something else in an orbit, you say it's falling.
Yeah,
So it's falling in a path
yeah.
of. So in which direction it's falling is just in the direction of its apparent movement.
They're
Not
both
apparent
that way.
movement, but it's
Everything
its actual movement.
everything
If
quote
we are
in
the Earth,
space,
if
any,
we are
any
on
kind
the
of
Earth,
mass that is
there
in,
is.
yeah, quote space. You know, like now we go back to this idea of imagining, because we have imagined ourselves placing this ruler down and going out a light year or so, let's say. You know, then you got, you know, like out past that, you know, like then, you know, gravity is this force, according to Isaac Newton, you know, which is directly proportional to the mass of the two bodies and inversely proportional to the square of the distance between the two bodies. Okay? That's the statement of the law about gravity. You know? And
Oh, it only has to do with.
things, you know, like
What
which
about
are
the
in
the
motion,
mass? What
tend
about
to stay in motion.
does that include mass or no?
Here's the thing. Mass is the thing which has gravity. See, mass causes gravity. You know, okay? And the
And
force
weight is a measurement
yeah, but
of.
listen to this. The second law of motion says that when a thing is in motion, it tends to stay in motion, and when it's at rest, relative to something, it tends to stay at rest.
That's inertia.
And it has been determined by people who have experimented since then that there's no way to tell the difference between gravity, which is gravitational as an inherent function of the existence of mass. You understand? Mass is that which produces gravity. That's what makes things have weight. You know, they have weight here because they're stopped. Because
Okay.
it's all its
Okay.
mass
So
here,
let's
see?
investigate mass,
Yeah.
because what it is the quality of the atomic structure of it,
Yeah.
the atomic quality of that substance,
And it's measurable.
that material. So therefore, the mass, the force of that mass, there's more.
Yeah,
Mass
the
has force.
The mass has a
The gravitational
Yeah,
force
but-
in the mass is going to depend on
yeah,
how dense it is.
yeah.
The density for example, a black hole. The
Yeah.
theory of when they look in a direction of where they propose a black hole to be, there's a density that's so concentrated that it seems like a concentration of gravity.
Well, there
So
is a
that
Lorentz
mass-
transformation. I never thought of that before. There's the possibility that you know, like because things are being accelerated at such a speed when you get close to the event horizon, then you know, maybe that's producing more of the gravity, you know, because it's being flattened out like a pancake. You know what I mean? It's traveling near light speed as it approaches the black hole. When it becomes dense enough, they say everything on
It
the
accelerates.
inside. But I've heard some other weird things which I've never been able to track down and verify in any kind of way. One is that all of the information on the surface of the black hole tells you what has fallen into the black hole.
I
And then
got
there's
to
another
question this with
Which
this.
Hawking talks about, you know, like where you got these
Oh,
pillars
Hawking.
of light, you know, like they're coming out of. You got all of this stuff. It's like in a galaxy, you know, like, and it's all going into the black hole.
Mm-hmm.
You know, and then you got these two beams that are coming up, you know, like at right angles to the galaxy. They're kind of like the pole of the galaxy,
Mm-hmm.
but they are radiant, you know, like powerful rays, you know, like I guess they're like pulsars and stuff,
Yeah.
you know, and
Well, doesn't a pulsar exist without a galaxy, or is a pulsar?
well, I used to
have
think they were
be in the-
stars, but you know, like the way that they're talking about it now, it looks like that the pulsar is a, you know, is a black hole. You know what I mean? There may be black holes that are existent other than in galaxies, and that they eventually, hell, I don't know. You know, I kind of wonder what the behavior of black holes is. You know, how could you affect them? You know, because they just kind of disappear.
All right. Well, now we have to talk about matter and antimatter.
Oh yeah, I never could figure that out. I could not buy that. They talk about positrons, like in
Yeah.
antiprotons, but like the only
Positrons.
thing that I know of is electrons and protons. A proton has a positive charge, and we can make a proton beam, like with a nuclear accelerator. You know what I
Okay.
mean?
Okay.
And
Hold on. Let's
like
get it.
electron beams
Hold
are
on.
in any
Hold on.
television set.
That's astrophysics and stuff. Now let's
Yeah.
go to nuclear physics. Hold on a second.